Welcome to another video. In this video, I'm going to solve this question. This question is from question number 8, part B from BHSEC 2022 paper, okay, mathematics paper. It says that show that this equation represents pair of parallel straight lines and then find the perpendicular distance between the line. Actually, the concept is like this. If we have the two lines, if this is an axis, and if we have two parallel lines, which means if this is our line and we also have this line, okay, and this line is given by the equation a1x plus b1y plus c1 equals to 0, and this line is given by the equation a2x plus b2y plus c2 equals to 0, then these two parallel lines, we just multiply these equations of line to represent the single equation like this, to represent both of the line like this, a1x plus b1y plus c1 times a2x plus b2y plus c2 like this equals to 0. Okay, so this equation is result of this multiplication. Now what we are asked to find is that actually this equation is already in this multiplied form. Now we have to find these two equations, okay, which the two equations which were multiplied before and got this answer. Okay, now there are two methods. The first one is that I will use completing the squares method. Okay, now we have that x squared plus 6xy plus 9y squared minus plus 4x plus 12y minus 5 equals to 0. Okay, now what I will do is I will try to group the term and make a complete square. What I will do is I will make a quadratic equation in terms of x. Okay, so what I will say is x squared plus this one and this 4x I'll try to group. Okay, so I will say 6y plus 4 of x like this, plus then our remaining equation is here 9y squared plus 12y minus 5 equals to 0. And I can also write like this, x squared plus, here I can take 2 common, so I can say 3y plus 2x, right, plus 9y squared plus 12y minus 5 equals to 0. Now what I will do is that I will say a equals to x. Okay, then I have 2 here and here a is here, and if this is b, then I have 2ba. Now recall that we have a plus b, the whole squared equals to a squared plus 2ab plus b squared. Okay, now what I'm doing is I'm trying to convert this to this form so that I can write in this format. Okay, so I have a squared is here, 2ba, ab is here, and now this b value is here, so that this should be now b. So if I say b squared, then I have to do like this. This remaining have to be just this 3y plus 2 the whole squared. So we have 3y plus 2 the whole squared equals to 9y squared plus 2 times of 3y times of 2, right, plus then this one 2 squared. Okay, so here we have 9y squared plus 12y plus 4, but here we have 9y squared plus 12y is already here, and now we need plus 4 to make this one whole square, right? So what I will do is in the next form I will add 4 here and I will add 4 here also, so that the equation won't change, but I'm completing the squares. Okay, now what I will say is I will say x squared plus 2 3y plus 2 x plus 9y squared plus 12y plus 4, okay, minus 5 equals to plus 4. Because I have added here, I have to add here also. then move this here, then it will become just plus of 9, right? So I will get x squared plus 2 3y plus 2x plus 9y squared plus 12y plus 4 equals to 9, like this. Now this one, this one, this one can be simply written as x plus 3y plus 2, this one, whole squared, right, equals to 9. If you expand this, you will exactly get this, okay? And when you expand using this formula, you will get this. Now I have to remove this square by taking root on both sides. So I have x plus 3y plus 2, like this, whole square equals to 9. By taking root on both sides, I will get x plus 3y plus 2, like this, equals to plus or minus 3. Okay, root of 9 is 3. Now we are getting these two equations that they have multiplied before. So if I say x plus 3y plus, if I take plus version of 3, then when it comes here, it will become 2 minus of 3. So it will be just negative 1 equals to 0. And if I consider this minus version, then when it comes, it will become plus of 3. So it will just become plus 5 equals to 0. Therefore, these two equations were the one which were multiplied like this to become this equation, okay? So if you multiply like this, x plus 3y minus 1 times x plus 3y plus 5 equals to 0, then this will become exactly this one. So this is the single equation of the parallel lines. And how do you know it's parallel? You have to see this term. In both the equation we have x plus 3y, x plus 3y, but this constant can be different. But if we have x plus 3y, x plus 3y, then the slope is same, which means that slope of first line, which is line 1, and line 2, when you take the difference, it will exactly give 0. So this is the condition for parallelism, okay? So this is the first method how you can find the two equations that were multiplied together to give this, okay? Now the second one is by using the quadratic formula. So we have from quadratic equation that the solutions, which is roots, can be found by this formula, right? Actually 4ac divided by 2a. Actually this formula is obtained by completing the square like this, okay? Therefore they are actually same. But if you don't know how to do this, you can directly put this in this formula to give the equations, okay? Now let us check this. For this also we need the quadratic form, which means we have to make use of this. So our equation is now x squared plus 6y plus 4 x plus 9y squared plus 12y minus 5 equals to 0. It should be in the form of ax squared plus bx plus c equals to 0, okay? So in order to make this, you have to consider this whole thing as c, this whole thing 6y plus 4 as b, and here a value is just 1, right? So by using this, we have to put this in the quadratic formula and it will yield the same result. Look carefully here. So our answer will be just like this. X equals to negative of this b, right? So 6y plus 4 plus or minus, then this b squared means we have to square this, so we will get 36y squared plus 6 times 4 is 24, right? And then we have to also multiply by 2, so it will get 48y plus 4 squared is 16 minus 4 of a value is 1, so you can directly multiply like this, 9y squared plus 12y minus 5 like this, divided by 2 times of a value is 1, right? So x equals to negative 6y plus 4 like this, plus or minus. Now see here, it is just 36y squared plus 48y plus 16 minus 94 is 36y squared, negative 412 is 48y, here is negative, so we have positive 45 is 20 like this, and this whole is divided by 2, and it will now have, see, let's see here, now it will be left with negative 6y plus 4 plus or minus, see here, this 36 will get cancelled, 48 will cancel, so now we have 16 plus 20, which is root of 36 exactly by 2. Okay, now x equals to negative 6y plus 4 plus or minus root of 36 is 6 divided by 2, and you can say x equals to, you can divide this whole by 2, right, to give exactly this value. So we'll get negative 3y plus 2 plus or minus 3, right? And then we can now have x equals to, if you shift here whole minus, then it will become x plus 3y plus 2 equals to plus or minus 3, which will be now x plus 3y. If you use the plus version of 3, when you shift here, it will become 2 minus 3, so it will be minus 1 equals to 0. X plus 3y. If you use the minus version of 3, then when it shifts here, it will become 2 plus 3, so plus 5 equals to 0. Therefore, we got the final equations, and if you compare this one and this one, they are exactly same. Okay, so you can do in two methods. You can either complete the squares, or you can directly use this quadratic formula to solve this. Now our second part of question is perpendicular distance between the lines. Now we know that we got two lines, okay, like this, and our two lines are this one, okay, first one, and second line is this one, but they are parallel in nature. So first one is x plus 3y minus 1 equals to 0, x plus 3y plus 5 equals to 0. Now what we are told is, we are told to find the perpendicular distance between these two lines, okay. So we have to find this. Now perpendicular distance is the shortest distance actually between the two lines, okay, between two lines. So what we can say is that we have that from the formula that distance equals to modulus of constant of the first equation minus constant of the second equation divided by the value of this a squared plus b squared, which is here and here are same, right? So our a value is 1, here b value is 3, here also a value is 1, and our b value is 3. Actually they are the direction ratios you will learn in different planes and all in different things. So it is like that. Now we have C1. What is the constant for the first equation? Our constant for the first equation is modulus of negative 1, and then minus, what is the constant of our second equation is 5, like this, modulus close, and then what is the value of a is 1 squared, plus what is the value of b is 3, so 3 squared is 9. So our value is now negative 6, like this, root of just 10. Okay, so our d value is now modulus of negative 6 is just 6 divided by root of 10 units. So this is the distance between the two lines. Or you can further modify this like this, as well as you can further modify as 2 times 3 root of 2 times root of 5, like this, and you can see that this one is just root of 2, right, times 3 by root of 5, then it is just 3 times 2 root of 5 whole square units. Okay, so this is the distance between the two lines. And why we use modulus? This is because we are taking the absolute value because the distance is always positive. Okay, that's why. And this is how you should solve. And this is a very interesting question, and this question is asked every year, so better to practice and then try to understand this process. I hope you all would have enjoyed this video, and I will see you next video. Thanks for watching and always supporting. I'm grateful for it, and it means a lot to me. Thank you very much. Bye.